Hello students, welcome to HB Kapadia School. First of all, congratulations to everyone to pass 10th with good marks. Myself is Kunal Pandya. I am the HOD of Physics Department, HB Kapadia School, and PM member, American Association of Physics Teachers. So today we are going to start our 11th standard Physics, and in Physics we will start with chapter number 3. It's quite relevant to the chapters which you have studied in your 9th and 10th standard. So we'll start with chapter number 3, that is motion in a straight line. Okay, this is our chapter. Basically we'll go with the line of NCERT, so it's better to keep NCERT with you, and in these conditions I will try to give you a PDF copy so that you can have a textbook online also. Yes, so chapter number 3, motion in a straight line. First of all, before going with this chapter, let's see which type of motion we are going to study in our whole syllabus. So different types of motion. We are going to study about rotational motion, we are going to study about circular motion, oscillatory motion, vibrational motion, and in this chapter we are going to study about linear motion. Okay, all these motions we are going to study in our syllabus. So first of all, let's have a brief introduction about all the types of motion which I have presented over here. So let's see, first of all, rotational motion. You might have seen these scenes in a movie. Yes, Marvel fans must have understood which movie is this, but we are not going for the movie. We'll just see the which type of motion is over here. Yes, the motion is rotational motion. Okay, it's the type of rotational motion over here. If you are not able to understand it properly, I have a different thing for you also. Yes, this is a fidget spinner. You have used this in your childhood and maybe in 9th and 10th standard also to have fun. So this is a fidget spinner, and when you are giving a motion to this fidget spinner, then of course it rotates and doesn't perform any linear motion or oscillatory motion. So basically when you are using a fidget spinner, it's actually a rotational motion. Okay, see, this is the central region. This is the central region of the fidget spinner, and about this the fidget spinner rotate, we can say this is called the axis of a rotation. Okay, this is called the axis of rotation about which the spinner revolves. So we are going to study about rotational motion in detail in chapter number 7 of part 1. Okay, so right now we are just supposed to know which type of motion is this. The name is enough. Now second type of motion, oscillatory motion. Whenever there is a to or fro motion, or a left and right, or a motion in up and down direction, like this, we can have a spring. Okay, when a mass is attached with the spring and it is moving like this, left to right, in this case the motion is said to be oscillatory motion. We have another example of this also. We have a example of a simple pendulum. See, in animation you are able to see there is a simple pendulum and it is oscillating about its mean position. So this type of motion, okay, these both the type of motions are said to be oscillatory motion. Okay, yes, vibrational motion are quite like oscillatory motion only. I will explain it to you also about the vibrational motion. See, whenever the oscillatory motion, see, this is the oscillatory motion. When the oscillatory motion becomes very fast, it means in a very less time it completes its full oscillation, then it is said to be vibrational motion. So there are very large number of similarities between oscillatory motion and vibrational motion. Okay, the basic thing is the oscillations are very fast, or we can say the periodic time of oscillation is very less. Okay, if in case of oscillatory motion periodic time is less, or we can say frequency is very high, then such a type of oscillatory motion is said to be vibrational motion. Don't worry about the definition at present, because we are going to study this in chapter number 14 in part 2. Okay, so right now just remember the general knowledge about the type of motion. So I have given a short picture which shows the demo of vibrational motion. See, we have a nut and bridge. We can also have two walls on which a nail is fixed, between which if we keep a rope like this, and if we, with the help of a finger, we just give a jerk, then it will perform vibrational motion. You are actually this is not a very large number of strings. It's just a single string, but when it vibrates, we feel as if there are very large number of strings. Such examples we can also have while flying a kite. When you are flying a kite, and if you are vibrating that string, then also you are able to see a very large number of strings at the same point, but actually they are not many strings, but it is just a single string. So this is a type of vibrational motion. You can perform this at your home also, with the help of a rubber band also you can do this thing. And in the lab you will see a vibrational motion like this. This is called a tuning fork. Okay, this is tuning fork. The practical diagram, or we can say practical picture, is like this. I will kept it for you. See, this is called a tuning fork. It is called a tuning, let me write, it is called tuning fork, and these are called the prongs of a tuning fork. See, these are called the prongs of tuning fork. Whenever this tuning fork is hit on a rubber pad, the prongs vibrates. Okay, the prong oscillates with very less periodic time. Okay, it oscillates very fast. So in that case, the motion is said to be vibrational motion. Okay, so in this case, the periodic time will be very less, or we can say frequency will be very high. Whenever you see a tuning fork, you can have the frequency is written over here. When you will see this thing in lab, at that time you will be able to see the frequency will be written somewhere over in these portions. Okay, so whenever you come to the lab, you will have these things written. The next, let's see the circular motion. Okay, around you also you can see the circular motion. The best example is the motion of moon around the earth, or we can say the motion of our end of a clock, or just the motion of earth around the sun. So such type of motion are called circular motion. So in this case, see, I have given an animation for a moon. See, moon or a satellite, and the satellite is revolving around the earth. The type of motion is said to be circular motion. Basically, there is a very less difference between rotational motion and circular motion. Sometimes some people misconcept about this thing. If we have a rod like this, see, this is a rod, and if it is fixed at one end with the help of a nail, okay, if we fix this point with the help of a nail, and if it is allowed to perform circular motion like this, okay, like this, if we give a force such that it performs a circular motion, in that case the rod as a whole, this is a rod as a whole will perform rotational motion. Okay, the rod will perform rotational motion, but the particles of rod, if you imagine a particle over here, then the particle of the rod will perform circular motion. Similarly, if you see a fan, ceiling fan around you, in that case the ceiling fan performs rotational motion, but the bolts which are there, or we can say if a particle is somewhere over there on the ceiling fan, then that particle or that particular bolt is performing circular motion and not a rotational motion. So basically, for a rotational motion, the axis should pass through the body. Okay, it should pass from the body, and in case of circular motion, the axis may or may not pass from the body. So it's quite simple. Again, if you see a fan, then the axis of rotation is exactly at the center, and all the particles which are not at the center for a fan will perform circular motion. Of course, the particles which are at very large distance from the center will have maximum radius for that particular circle. Okay, see, this is a diagram, or if this is one of the particles, another particle is at this point. When this rod performs a circular motion, the particle at this end will have a larger radius, whereas the particle which are near to the center will have less radius. Okay, the radius of all these particles will be different. Now comes the linear motion. Yes, this is the thing which we are going to study in this chapter, linear motion. Okay, linear motion, you have many examples with you. Let me show you with the help of some animations. Yes, the motion of a car moving on a straight road. Yes, of course, that is, it should be a condition. It should move on a straight road without any speed breaker, or it should not move on a slope. Exactly, if it is moving on a straight horizontal road without any turns, then we can say the motion of car is said to be linear motion. Similarly, the motion of cycle is said to be a linear motion. Any vehicle which is moving exactly on a straight road, we can say it is performing linear motion, and we are going to study about linear motion in this chapter. Okay, this chapter is totally dedicated for linear motion. So let's see some basic definitions before starting this chapter. We have the definition of kinematics. See, kinematics is a branch of physics. Okay, it is a branch of physics which deals with motion. Of course, we have to study the motion in this case. Okay, but we are not going into the no, we are not going into the causes of the motion. Okay, so if we are studying the motion but not its cause, then it is called kinematics. Okay, for example, if you are driving a bike without knowing how the bike runs, then we can say you are just studying the kinematics. Okay, again, if you are watching a Ferrari car, okay, if you study the motion of a Ferrari car, that it is moving with a speed of 50 km per hour, it is sorry, 50 will be insulting for the Ferrari. Imagine if it is moving at a speed of 200 meter per second. Let's imagine. Okay, so if it is moving at a speed of 200 meter per second, if you note down, and after that if it comes to rest in within 1 or 2 seconds, again it goes to 0 to 100 in 3 seconds, then we can say we are just dealing with the motion and not the causes. Okay, we are not going into the cause of the Ferrari car, that it is having this much horsepower of engine or this much cc of engine. So those are called the cause of motion. Okay, so if we are studying the we are studying the physics, we are studying the motion. Okay, if we study the motion but not its causes, then it's called kinematics. Okay, so different from this is a dynamics. In case of dynamics, we'll study about motion along with its causes and properties. Okay, we have to study the motion. Yes, we have to study that Ferrari gets a pickup from 0 to 100 in just 2 or 3 seconds, and we are also going to study its properties, that it's have a good tires, it's having a good ball bearings, or good oil is used, or good fuel is used, or some engine is overpowered, or we can say those are called the causes of motion. So if we are dealing with the motion along with its causes and properties, then it's called dynamics. Okay, now let's see next. What about if we study these things at one time? If we study both kinematics and dynamics, then the combined study of these two things, the combined study of kinematics and dynamics, is called mechanics. Okay, mechanics is a combined study of kinematics and dynamics. Some people also think that yes, the dynamics is also somewhat like mechanics. Okay, you can say in such cases, in some cases we can say that kinematics and dynamics combined study is called mechanics, and dynamics is similar to mechanics. Okay, so just remember the definition which is given in our textbook. Yes, combined study of kinematics and dynamics is called mechanics. So let's proceed further. So this was the introduction of type of motion given by me, and now we'll have introduction according to NCERT. See, in our videos we'll always follow NCERT. Okay, we'll not lose the contact with NCERT, we'll always follow the NCERT lines. Okay, because without NCERT you'll not be able to understand the concepts better, and also you'll not be able to cover the syllabus as a whole. So let's see the NCERT lines. Yes, the introduction part is given. Introduction part are people think that it's not important. Yeah, it's not important for examination point of view, but you should study that part in order to know the physics. You can have some you can create some interest when you go through the introduction part. Always introduction part gives us a target or a motive to study the chapter. Okay, so I will prefer you should go through the introduction part. So I have not written all those things which are there in introduction. I have just point out the main things which are very important in this introduction part. So the things which are important are these are the pure NCERT lines. We shall confine ourselves to study of motion of objects along a straight line. Yes, in this chapter we are going to study only about motion on a straight line. Remember this linear motion, is also called rectilinear motion, because it is having a rectangular coordinates. What are rectangular coordinates? Question may be in your mind, but I'll not be able to give that answer right now. Okay, for that you will have to study 2-3 chapters more. You have to wait for some lectures more actually. So linear motion is also said to be rectilinear motion. These are one and the same things. So in this chapter we are going to study the objects about the objects for a motion on a straight line only. We are not going to study about motion in 2 dimensions. It's there in chapter number 4. So in kinematics, okay, yes, this is also the definition which is given in with the definition of kinematics given in our NCERT. In kinematics we study ways to describe motion without going to its causes of motion. So I just explain it to you. If we study the motion but not its causes, then it's called kinematics. Now the main thing starts, motion. See, right now I will give you some brief introduction about motion, and in our next lecture we will go into the detail with motion. Okay, so right now we'll just see some basic definitions of motion. Okay, yes, I promise I will give you a detailed concept of motion in our next lecture. Okay, because it's not in the sequence of NCERT. In the sequence of NCERT, motion comes somewhat 1 or 2 lectures later. So yes, this is a definition. When an object changes its position with respect to some other body, then the object is said to be in motion with respect to body. This definition is very, it seems to be complicated in first glance, but later on, if you get familiar with this definition, you will study you will be able to understand it better. When an object changes its position, okay, imagine this, suppose an object, this is object, okay, and this suppose a body, this is a body. Okay, when the object changes its position with respect to that body, then the object is said to be in motion with respect to that body. It's very simple definition, and I will go in detail about this thing in our next lecture. Okay, so right now just try to remember this definition. I will not tell actually to remember this definition. So whenever an object changes its position with respect to a body, then the object is said to be in motion with respect to that body. See, motion is a reference. We can, without any reference, we cannot define motion. So I will explain it to you in next lecture. Now, yes, remember this thing also, with respect to or with reference to. I will not write down these things in detail in later part of this lecture. Just remember WRT. Whenever I write W.R.T, then you have to remember that it's with respect to or with reference to. Okay, I may in words also I can speak WRT. It means with respect to. Okay, so it's not like this is legal thing. Okay, don't think that I have made a short form my way. Okay, this is the legal thing, and you can write in your examination also. So with respect to or with reference to. Okay, both are one and the same thing. It's WRT. Now let's see some basic definition. In order to study the motion, remember I have just uttered the definition of motion. I will explain the definition of motion in detail in next lecture, but for that we'll need some different kinds of definitions also, different types of concepts. Yes, the concepts, first concept is that of a reference frame. Okay, reference, see, you have seen, like, this is suppose a spectacles, or we can say it is a glass frame which you are using for your spectacle. Okay, so this is suppose a glass frame. Okay, in this glass frame, what you are doing, you are just keeping your glasses. Okay, similarly, in order to study the motion, see, my sketch is not good right now, so bear with me. Yes, so if you imagine a glass frame or any type of frame, the frame actually is a thing in which something is fit inside it. Okay, if we fit something inside a border, we can say that border is said to be a frame. Similarly, if we are going to fit a motion inside x-axis, y-axis, and z-axis, then it's said to be a reference frame. For example, let's see the definition. It's a point or situation from where the observer takes his or her observation is called a reference frame. This is a definition given in our textbook. Again, a reference frame is defined as a point or a situation from where the observer takes his or her observation. So from where we take the observation, it's called reference frame. We'll come to this definition again. It's weird, I know. Yes, in order to have a reference frame, you have to take 3 mutually perpendicular axes. you have to take x-axis, y-axis and z-axis, and the rule is we have to take it in anti-clockwise direction. Okay, this is a very important condition. We have to take x-axis, y-axis and z-axis in anti-clockwise direction. I think you have taken this x-axis, y-axis and z-axis in your coordinate geometry part in mathematics before. Okay, so you have to take x-axis, y-axis and z-axis. How we have to take x-axis, y-axis and z-axis? It is written anti-clockwise direction, but it's not quite imaginative. Let's see how we are taking. If we have three mutually perpendicular axes, these are perpendicular. Over here it's perpendicular. Over here also we have taken these two are perpendicular to each other, and over here also these two are perpendicular to each other. So you can see these three are the mutually perpendicular axes, and in this mutually perpendicular axis we have to take x-axis, y-axis and z-axis in anti-clockwise direction, or we can say counter-clockwise direction. It means if we have taken x-axis at this point, then if we imagine a watch over here, this suppose a watch or a clock, in the minute hand, or we can say any hand of the clock moves in like this, it moves in the clockwise direction, but you have to take the anti-clockwise direction. Means you have to take the direction like this. So if this is the x-axis, y-axis should be there in the anti-clockwise direction. We'll get y-axis and z-axis like this. You have to take it out from the plane of paper. Okay, right now I have drawn this z-axis like coming out from the plane of your screen, because actually you are watching this somewhere on your screen. So z-axis actually it's coming out from your screen. Okay, in examination you have to write it's coming out from your paper. Okay, yes, so this is x-axis, y-axis and z-axis. These three are the mutually perpendicular axes, and we have to take it in counterclockwise direction, or we can say anti-clockwise direction. Yes, I have made this many coordinates. Okay, there are too many methods to take x-axis, y-axis and z-axis, and some people also make mistakes in taking x-axis, y-axis and z-axis. It's very simple. First of all, I will show you how the things are right. Okay, how can you take x-axis, y-axis and z-axis, and how you cannot take x-axis, y-axis and z-axis. Okay, so first of all, if this is the x-axis, then in counterclockwise direction this will be the y-axis. Okay, this is x-axis, and then in counterclockwise direction you have got y-axis. If this is the y-axis, and again in counterclockwise direction again you have to take z-axis, because after y comes z. Okay, again if this is z-axis, then what comes after z? So in our ABCD, in our alphabet, first of all it comes x. Okay, after x comes y, after y comes z, and after z comes x. Okay, remember the sequence: x, y, z, x again. So after z will come x-axis. So these three are very correct method to represent the coordinate axis. Okay, x, y and z axis, they are taken in counterclockwise direction, or we can say anti-clockwise direction, and these are the three perfect methods. Okay, yes, we have forgot to keep the third axis. If this is x-axis, this is y-axis, the remaining axis z, that is coming out from the plane. Here also the third axis is x-axis, it is also coming out from the plane, and this will be the y-axis. Okay, so these three are the correct methods. Now I will show you the incorrect methods which people often do in the examination, because when we check the copies, when we check your papers, we often encounter with such mistakes. Okay, because people in hurry can do such mistakes also. So I will also show you that these things are wrong. Okay, this is wrong. First of all, let me write this is wrong. Okay, you are not supposed to take the coordinate like this. If you have taken x-axis like this, you can never take z-axis over here, because after x always comes y. Similarly, if you have taken y-axis over here, then always it comes z. You cannot take x-axis. You are taking x-axis and it's wrong. Again, if you have taken z-axis over here, then you have to take x-axis. If you have written y-axis, then also it's wrong. Okay, so these three things which I have drawn in the lower part of the screen are wrong, and in the upper part of screen which I have drawn is totally correct. Okay, so always try to follow the first upper three part of the coordinate system. So I hope it's clear. We have to take three mutually perpendicular axes. Okay, there should be three mutually perpendicular axes, and those axes they should be perpendicular to each other, and always we have to take it in anti-clockwise direction. Okay, remember this anti-clockwise condition is very important. So let's see next. Again, let's see the definition of reference frame. Yes, again the point or situation from where the observer takes his or her observation is called reference frame. We have to take, see, don't worry about this definition at present. Let's clear the concept about this thing. Yes, we have to take three mutually perpendicular axes. We have to take x-axis, we have to take y-axis, and we have to take z-axis, and we have to take these three axes in anti-clockwise direction. I hope anti-clockwise direction part is clear to you. Now let's see next. Here comes the definition of a reference frame. I just told you that point or a situation from where the observer takes his observation is called a reference frame. Now it's time to understand that thing better. See, I just told you that we'll go through this definition right now. So here comes the basic definition of a reference frame. So as shown in figure, you can have two observers. Yes, there are two observers, observer O and another observer is O dash. There are two observers, and these two observers are observing an event. See, over here there is an event, and these two observers are observing that event. So when these two observers observe that event, then this both observer will have different view of that event. For example, this observer which is at O, okay, the observer which is at O, we can say for his eyes, the event is taking place at somewhat this much distance away. Okay, like this distance is suppose D, and for this observer which is over here, okay, at O dash, the observer which is at O dash will have some less distance, let it be D dash. So over here these are the two observers and they are observing an event. So basically the reference frame are different, so that's why they will have a different distance from the event. So in this case also we have taken x-axis, y-axis and z-axis. Okay, also here we have taken x dash, y dash and z dash. There should be some difference between those two. So basically the definition of reference frame over here becomes, this is a point. Yes, we have also mentioned a situation for you. See, this observer is moving with velocity v. Okay, the velocity with which this observer is moving is suppose v. So in that case, see, v is equal to d by t, distance covered upon time taken is called v. Therefore we can say d is equal to v into t. So the v into t indicates the distance. Okay, actually these two observers are observing the same event, but if they are having different velocities, then also the event appeared can be different. Okay, so this can also be taken like an we can also take an example of two trains. See, if you are going towards a north direction in a train and another train is coming towards the south direction, in that case if you reach at a platform, let us imagine an event which is happening at that platform, then at a particular point some people can say that event is occurring in north direction and some people can say that event is occurring in south direction. So for both of them the event is there on the platform, but the situations of those two people are different. Okay, yes, tell me in the comment section which passengers will feel that the event is occurring in north direction and which passengers will feel the event is occurring in south direction. Okay, please mention this thing in the comment section. If you have not understood what I have said, please go through the video again and understand it better and tell me in the comment section that which passengers will what. Okay, yes, so basically when you are sitting on a train and if you are observing any event, you can say you are there in a reference frame of a train, or we can say the point or situation from where you are taking the observation, the point or a situation is there inside the train and you are having x-axis, y-axis and z-axis itself in a train. So therefore you are basically there in a reference frame. Okay, you can also take another example. See, when you are watching the sun Actually sun is stationary and our earth is rotating, but we feel as if the sun is moving. Okay, so basically we can say we are there on the earth and we are having our own reference frame, and according to our own reference frame the sun is moving, but actually it's not moving. So what's reference frame? It is a point or situation from where the observer takes his observation. Remember this definition forever. Let's see next. We have to go through some different definitions also. The definitions of position, path and displacement. Position, let's see the first definition. Position. Yes, position needs two things. It needs a reference point, also it needs a reference frame. What does this mean? Imagine if you are your home is at a distance of 2 kilometer. Just just the data. Okay, if someone is asking me that where is the person, like where is Rahul? Okay, imagine a person named Rahul. Okay, where is Rahul living? Where is Rahul's house? If I say it, his house is just 2 kilometer, then do you think this 2 kilometer data is enough to find Rahul's house? No. With the help of just 2 kilometer data, we cannot find out his house, but we have to mention that 2 kilometer from a reference point. Okay, we have to mention a reference point. Imagine 2 kilometer from HBK school. Okay, 2 kilometer from HBK school. Then too you will not be able to find out his home again, because 2 kilometer will be anywhere. Okay, and he can live anywhere around 2 kilometer. So in that case you will need a reference frame. Reference frame means what? If HBK is considered to be the reference frame, we can say it is a point or situation from where the observer is taking his observation. We have to make x-axis, y-axis and z-axis, and in that case you can find out its position, that he is living along a negative x direction, this much distance, and positive y direction, this much distance. So in that way you can find out his position. So for position we need two things. We need a reference frame and also we need a reference point. Let's go further. Let's have another example. The basic definition of path length and displacement. See, I'll give you an example, and with the help of that example you will be able to understand what exactly path length and displacement are. So first of all, I think the concept of a position is clear. Position needs two things, reference point and reference frame. Now later part is the part of path length and displacement. So here I have given a fine example to understand path length and displacement. Imagine, suppose this is what you imagine, I don't know, but some people have they have not imagined, but they are able to see that this is the cartoon of, yes, Iron Man. Okay, if you are not a Marvel fan, no problem. Okay, this is a person standing over here and he wants to meet this person. Yes, people also know who she is. Okay, yes, imagine a person standing at this point A, suppose. Okay, person is standing at point A and he wants to reach and meet to a person which is at point B. So for that, yes, he is out of his fuel and electricity, so therefore he is hiring a rickshaw, and this rickshaw wala takes him to point B along this path. It is a very long path in order to gain more money. So yes, he also has lost his GPS connection, so he is not able to understand. She is just 5 kilometers away. So rickshaw wala took him to a longer path, 10, 10 and 5, it becomes 25. So this is actually the length on which the object is moving. Imagine, suppose this is the object, it is moving along this path. Okay, the length of this path on which the object will move is called the path length. So in this case you can see the path length will be 25 kilometer. Okay, this will be the path length, 10 plus 5 plus 10. Okay, it will become 25 kilometer. Now let's see what's displacement. Displacement is just the shortest distance between any two points. Over here the shortest distance between point A and point B is, yes, we can see it's 5 kilometer. So displacement in this case will be 5 kilometer. Okay, so this is the displacement. So I hope it's clear. Path length is also called displacement. Remember this thing, this path length is also called displacement. Let me write, it is very important thing. Yes, sorry, path length is not called displacement, path length is called distance. I'm very sorry. Path length is also called distance, and displacement is also called change in position. Okay, displacement is also called change in position. For this particular case, the distance covered is 25 kilometer. In this particular case, the displacement in this case is 5 kilometer. Okay, if the rickshaw wala is honest, then he will have a displacement, and if it is not, then he will have a larger path length or a larger distance. So let's see some information we got from this example. Magnitude of displacement may be equal to distance. So what do you think, when will these things be equal? Magnitude of displacement and distance are equal. See, imagine if this rickshaw is not there, if this our Iron Man is moving from point A to point B on just this straight linear path, in that case the path length will be 5 kilometer, displacement also will be 5 kilometer. Okay, in this case, in this particular case, the path length and displacement will be equal. So again, let's see the definition. Sorry, important point. Magnitude of displacement may be equal to distance. Yes, we can have magnitude of displacement and distance are equal. When is they are equal? When the particle is moving along the shortest path. Let's see the next point. Magnitude of displacement can be less than distance. Magnitude of displacement, just now we saw, see, if he is moving exactly along the straight path, path length is 25 kilometer and displacement is 5 kilometer. So in this particular case, the displacement, the magnitude of displacement is less than the magnitude of path length. Let's see next. Magnitude of displacement can never be greater than the distance. Okay, see, this person is going along this path, distance is 25 kilometer, displacement is 5 kilometer. It's never possible that this displacement can be greater than path length. Okay, it's never possible. Displacement always is less or equal to, I will write it is, displacement is always less or equal to path length. So please remember this thing also. Let's see next point. For a given course of motion, the displacement may be 0, but path length can never be 0. How is this thing possible? So if the person whom the Iron Man wants to meet, see, this is point A and this is point B. If this rickshawala takes him along this path, in that case, in this particular case, the path length or distance will be 30 kilometer and displacement will be 0. Why? Because initial position at this point and the final position also is at the same point. So in that case, the change in position, or we can say displacement, is totally 0. So if the displacement and if the displacement is 0, even though the path length is not 0, so again let's see the last point. For a given course of motion, if the motion starts from the same point and it ends also at the same point, then we can say the displacement will be 0, but path length will not be 0. So this is the example which is given in our textbook. It's also a good example. Let's see this example. Yes, the particle is starting from point O. See, this is point O. Particle is starting from point O. See, this is the figure 3.1 of our textbook. If you have a textbook, you can open the textbook and see these things. Yes, the object is moving from point O to point P. Object is moving from point O to point P and then to point Q and then to point Q. In this case, we have to find out path length and displacement. Okay, we have to find out path length and displacement. Path length is what? It is exactly the distance, or we can say the path on which the object is moving. So over here, the path length will be from O to P. The path length is, or we can say the path length for OP and from P to Q. If the particle is moving from point O to point P, then see, you can see from the diagram, the distance OP is 360 meter. Okay, where is meter written over here? See the diagram. In diagram it's mentioned clearly that all those things are in meter. And from when it is moving from point P to point Q, we can say the distance V is just 120 meter. I will add 120 with this thing, so total becomes a 480 meter. Okay, so over here for this particular case, the path length or distance traveled is 480 meter. Now let's see the displacement. See, what's the initial position? Initial position is O and final position is Q. So we can say that displacement in this case will be OQ. O to Q is just 240 meters. So in this case it will be 240 meter. So this is our answer. The displacement of the particle will be 240 meter. Okay, and the path length is 480 meter. This is the example which is given in our NCERT textbook. Let's see next. Yes, these are the basic difference between path length and displacement. Remember this thing, you have to write it 3 times. I will check these things when the school reopens. Path length is also known as distance. I have said this thing before also. The path length is also known as the distance. Displacement is also known as change in position. Remember this thing, the path length is always positive, it can be never be negative, because once started, okay, it always will increase. The meter of a rickshawala will not decrease in any case, it always increases. Even if you take a U-turn and come back to your home, in that case also the meter in the rickshawala will give you a positive reading. Yes, the displacement may be positive, negative or zero. It is nothing to do with the this positive value. Sorry, not, it can be a positive, it can be a negative, or it can be a zero. So if you are taking a U-turn, in that case the things which are positive, if this is positive, in that case, in the later case it will become negative. Okay, and finally it becomes zero, because initial position and final position becomes equal. Yes, the path length is a scalar quantity. Path length is scalar quantity. Scalar quantity needs no direction. This is the vector quantity. Vector quantity needs direction to get specified. Okay, what are vector quantity? We'll study in chapter number 4. In chapter number 4 we have too much details of vector quantities. Chapter number 4 also, and in chapter number 6 also we'll study vectors in detail. Yes, path length is equal to or greater than displacement. This point is also clear. See those 4 points which I have explained it to you just a few minutes before. Yes, displacement is always equal to or less than distance. This point is also clear. So yes, homework. In homework you have to write this table, take the screenshot, take out the screenshot and write this table 3 times. Nothing else is your homework. Okay, you have to remember this table only. Okay, you not just remember, also understand this table in a better way. So thank you very much. This video was by Kunal and Pandya sir, and I am there in HBK school. We meet when the school reopens. In next lecture we'll study about basic definitions of average velocity, average speed and average acceleration. Okay, so wait for our next lecture and prepare this lecture well. If you have any doubt, you can write it in comment section. I will make a separate video for you people also. So thank you very much. We'll meet in our next video. Thank you.